let's get some simple notes here. So changing back and forth, these rational exponents can be written two ways, and I'm going to show you. I reduced my. I'm going to hit a full window here. Hold on. There we go. It can be written two different ways, and I'll show you them. All right. So I can take. Remember, if I look at this, there's a couple ways to do it. All right. One way is like this. I can put my power on the letter inside the root, right? So if I did that right here, this would be 27. Remember, the power is in the numerator. The root is in the denominator, like that. Or a much better way to do it is to go ahead and put the power on the outside and take the root first. Over here, I'll show you why this is better, because if you do this, it's really easy to do in your head. Put the power on the outside and the root first. If you think about this, well, the cube root of 27 is 3, and 3 squared is 9. It makes it really easy to do in your head. This guy makes it tougher. I don't know 27 squared. So if you do the root before the power, it makes it a whole lot easier. So there's two ways to do it, and I'll show you them. All right. We'll do both. All right. Both of them have a power, right? It looks like this is the square root. You do not have to write a 2 in your square root, but I'm going to put it there. One of them puts the root here. One of them puts the power inside, and one of them puts the power there, right? This one's easier, because the square root of 4 is 2, and 2 cubed is 8. Kind of easy, right? This guy can be written both ways. I could say, hey, let's do both. All right. Either I can put my power on the... Oh, I take that back. They've already written as a rational expression, as a radical. And let's write it as a rational power. All right, we're gonna take that exponent and do a rational exponent. The 5 goes on top and the 2 goes on bottom. All right. So, and again, this is taking a radical expression, writing it as a rational exponent. This is taking a rational number, that's just fractional, exponent, and writing it as a radical expression. I'm going to show you how some of these are easy. It says, translate the radical expressions with rational exponents and vice versa. This is totally easy in so many cases. All right. So if I had negative 125, I could do my root first and then my power. Well, the third root of negative 125 is negative 5. Quantity to the 4th power, which we get 625. Alright, this one we're just going to write. I'm going to say x to the 8th root and 11th power. Kind of quick. This guy we're going to say 6 to the 4th root and the 5th power. I would need a calculator to do this, right? This would take a calculator, and this would be x to the 3/4 power. Now, I'm going to show you one way to do this on a calculator. Alright, if you get a calculator, you would like to do this. Alright, you can take your calculator right here. Alright, and if I want a root, I can put a 4 there. Alright, and then I can hit math, and right down here, it'll let you use that 4 as your root. And then you can say raised to the 5th power. Uh-oh, I never put my 6 in there, did I? There's my 6. Raised to the 5th power. And if you get that, it should give you an answer, which is roughly 9.4. And you know what? I'm going to write that in. This is approximately, squiggly line, 9.4. I'm going to do a few more on the next page. Alright. So, which is this page right here. And let's go. So, whenever time you see a radical expression, write it as a rational exponent. And every time you see a rational exponent, write it as a radical equation. Look, I can do this one pretty easy. I'm going to actually zoom in so you can see it. My pencil may even hit the camera. So look, I'm going to say 81 over 16. And let's take it to the 4th root first and then the 3rd power. Well, the 4th root of 81 is 3. The 4th root of 16 is 2. Take all that to the 3rd power, which gives me 27 over 4. Not too bad, right? Now when you do this guy, make sure you keep the x and y together. And probably the easiest way to do that would be to put the root there and the power here. If you choose to put the power on the inside, you must put these guys in parentheses or put a 5 on each one of them. Either way. Ooh, this is a good one to do right here. Watch G. G's good. That is 6 to the 6/3 power. And even though that is a rational exponent, you can reduce it just like a fraction. 11 squared, which gives me 121. All right, not too bad. This guy right here, we will write it all 2x over y raised to the, remember, this is your power, right? Up top, numerator has my root, 5/3 power. Doing this guy, we're going to write this guy. That is a rational exponent. So we're going to go ahead and write that as a radical expression. Our root is off the denominator. We got negative 6x. Our power is there. Remember, there's two ways to write that. All right, I could also put my root right there and my negative 6x, probably in parentheses there to make sure we're okay, squared. All right. So once again, I'm just going to write this one way. My root goes right there from the numerator to there. 3y, we'll raise that to the b power. Oh, here's another one we can do in our head. Watch. All right. So we're going to say 0.5, which by the way is 1/2. That's our power to the 9/3 powers. Let's write it as 1/2. 1/2, and 9/3 reduces to 3. And then we have 1 to the 3rd, which is 3, 1, and 2 to the 3rd, sorry, which is 8. All right, we'll do one more here. Make sure you use that entire st, so I'm going to put st in parentheses to the vu power. vu power. Hey, it's almost done with page 2. I'm going to pause this. And 7 minutes, not too bad.